Yesterday I concluded the grade 11 probability with the contingence table. Right? I am going to introduce what's called the fundamental counting principle, which is a totally new concept to your maths, and this is the final topic of your grade 12 maths. Right? Now, the fundamental counting principle is all about finding the number of combinations, the number of ways things can happen. Okay? So, what does the fundamental counting principle say? Now, basically, if you are given, say, task 1, and you are told that it can be performed in N1 ways, okay? And then you are given task 2, and you are also told that it can be performed in N2 ways. So here we have two tasks, task 1 and task 2. Each of those two tasks can be performed in specific ways. Now, sometimes we may need to know what is the chance or the number of ways you can do both. Okay? Now, in that case, you just have to multiply the number of ways of each task. So here we have got two tasks, task 1 and task 2. Task 1 can be done in N1 ways, task 2 can be done in N2 ways. Okay? Now, we may need to know in how many ways can both tasks be done. In that case, you just multiply the number of ways of each task and you get a product. So if you have got two or more tasks, all you just have to do is multiply the number of ways of all those tasks and then get a product. Okay? Now, it may be a little bit tricky, but I can extend this to times N3 times N4 times all the way up to infinity. So we call this the fundamental counting principle. Now, for you to be able to understand it much better, I've got a nice example here of what this is all about. Yes?
So you can only use the counting principle once you have two or more.
Yes. When you have got two or more ways. Okay. Sometimes you have what are called restrictions, which I'll talk about probably later or maybe tomorrow. Okay. So the basic idea is just to multiply the number of ways of the tasks. Now, the nicest example is the case of someone who goes to a restaurant and then they are given a menu. Okay. So you have got starters. In this case, you have got 3 starters. You have got chicken livers. I don't like that. Then you have got tomato soup, and then you have got salad, right? And then you have got a main meal. You have got the peri-peri chicken. Can I have your attention? You have got peri-peri chicken. You have got lamb chops. You have got beef ramp, and then you have got fish and chips. I like fish and chips, right? And then when it comes to dessert, you have got fruit salad and ice cream, and then you have got some, chocolate pudding there. Now, can I have your attention? Can I have your attention? So, the question will be, in how many ways can a person choose one starter, one main meal, and one dessert? Okay, in how many ways? So if you look at the question here, it says, if one starter, one main, and one dessert is selected from the menu, how many combinations of a starter, a main meal, a dessert could be chosen? Okay? Now, to get the answer here, we use the fundamental counting principle. So, your starter is like task 1. The main meal is like task 2. Then the dessert is like task 3. So, if you want to determine the number of combinations, it will be equal to the options you have for the starter, there are 3, times the options you have for the main meal, there are 4, times the options you have for the dessert, there are 2. So if you multiply here, you get 24 combinations. Okay, so a person has got 24 options. in terms of what they can choose, in terms of one starter, one main meal, and one dessert. Okay, so this is a simple example of how we can apply the fundamental accounting principle. Please remember, as I've told you, the last question of your paper one, that's where you see questions of this type. But there are different types of questions. Yes? Other questions? Yeah, the whole topic on probability, grade 10, 11, and 12, 15 marks. So the counting principle normally to be around 7 or 8 marks. And some of the questions can be so easy that you can easily write the answers quickly and then you move on. All right? Okay, allow me to move on. To today's lesson, I'm going to move a little bit quick. Okay, please do me a favor. If you are a little bit slow, you might have to catch up later. The most important thing is listen to what I'm saying as I introduce this topic. Okay. Remember, I told that I don't want to call you to come on a Saturday. I don't want that. Right, let's move on to another example. Now, it's going to get a little bit complex now with this one. So, the question says, there are 3 vacancies at a specific company. The company has shortlisted candidates for each position. Right? So, we have got the post here. There are 3 posts. We have got an admin clerk. Now, there were 3 candidates for that admin clerk post. Okay? Then accountant, there were 4 people. And then the personal assistant to the CEO, there were 2 people probably who applied, maybe they were shortlisted. Then the first question says, how many ways can these positions be filled? Okay, how many positions? Now, this will be very straightforward. Okay, so your posts are like your tasks. So you've got task 1, task 2, task 3. Then the candidates are going to be the number of ways for each task. So we use the fundamental accounting principle. Okay? So for A1, okay, number of ways. This will be equal to, there are 3 for the admin clerk. Then there are 4 for the accounting position, and then there are 2 for the personal assistant position. So the total number of ways here is going to be 24. All right. Are you following what I'm doing here? Yeah. So this is basically the easiest part. Now the second question now becomes a little bit more complex because it has got what's called a restriction. Okay. So the next question says, how many ways can the positions be filled if it is certain that Donald will get the job as an accountant? Now there is a restriction now with regard to task 2. So among those 4 people, it's guaranteed that Donald will take that position. Maybe he might have connections at that company, right? He might know someone who pressed the buttons for him to get. Yes, it happens in real life. Right? People press buttons for others to get. Yes, right? Or maybe he might be the most highly qualified in experience for the position. It's also a possibility. All right. Okay. The way that I'm going to explain. Can you stop talking, please? Pay attention. So your number of ways. Okay. We have got 3 tasks. Okay. So the first task, I'm going to represent it by that horizontal line. Now, that's for the admin clerk. There is no restriction. Okay? So, all three people, they stand a chance of taking that position. Okay? Then the next position, which is for an accountant, based on the question, it's only Donald who is supposed to get it. So that would be 1. So put 1. Alright? How would I know? It's written here. It's written. The question says, how many ways can the positions be filled to be certain that Donald, can I have your attention please? Can I have your attention? Donald has to get the job as an accountant. Okay? So there are three options for the admin post. Then there is now one person who's going to take the accounting position. Then the third task or position for the personal assistant, there are still two people. Then we apply the fundamental accounting principle, we just multiply those two. Okay, remember the fundamental accounting principle is to do with multiplication of the number of ways. So this will be 6. Okay, the answer there will be 6.
I'm so confused. Why is it like 3 over
3 over 3. Is this not a probability? Okay, don't confuse probability and what I'm doing here. We are not calculating probabilities yet. We are going to do that later. Can you please do me a favor? It's not going to benefit you if you talk without control. Because this topic is a little bit tricky. Okay? It's a little bit tricky. And I'm telling you this from experience. Okay? So, and sometimes it doesn't have a specific formula to get the answer. You just have to use common sense. Okay? So here, there are 4 people for the accountant position. But for the second question now, there is a restriction which says Donald will get that post. Which means the other 3, they stand no chance. Okay? They can never get it. It's for Donald. Okay? Alright.
So, yes, I have a question. For example, when you say that Donald can only be full, only Donald can full as the person accountant, but not as a new applicant for the admin person. Is it possible?
Okay. Generally, for a type of question like this, you don't introduce other people. You understand? For a type of question. Alright, let's move on to another one. Alright. Now, this question says, in the diagram below, there are 3 routes. Can I have your attention, please? There are 3 routes from A to P. So from A to P, there are 3 routes that a person can take to travel from A to P. Then there are 4 routes from P to Q. So you have 4 options. Maybe there is traffic here, you choose that one, or you choose that one, you choose that one, and so on. Maybe there's a road construction on this route here. You hear about maybe on East Coast Radio or another way that you know. Maybe you've got an application which tells you which road is not okay. Then you can choose the best option. So it says, in the diagram below, there are 3 routes from A to P, 4 routes from P to Q, and 2 routes from Q to B. Okay? So Q to B, there are 2. How many different routes are there from A to B? Okay? Via P, P and Q in the direction of the arrows. So we are following that direction of the arrows. To the what? To the right. Now, so here, number of different routes. Number of different routes is going to be equal to, now, in terms of tasks, how many tasks we have? We have 1, 2, 3, right? The first one, we have got 3 options, okay? Then the second one, we have got 4 options, and the last one, we have got 2. So there are going to be 24 different options. Okay? There are going to be 24 different options that you may have to choose for you to get to B. Yes?
You only have to say number of different.
Yeah. No, it depends with the question. You see, the question is asking here how many different routes? How many? So when you are answering, it will be number of different what? Routes. And then you do the multiplication. Hello, are you following? Huh? Right. Now, this is more like the easiest part. Now, I'm going to get a little bit more complex. Okay. So let's introduce the cases where there are some restrictions now that are very clear. The first case is when repetition is allowed. Now, in cases where repetition is allowed, the number of possibilities is always equal to n to the power of r, where n is the number of options to choose from. That's the total number of options to choose from, and r is the number of times we choose from those options that are in n. So it's more like r is less than what? N. And we call this the exponential form. This is the exponential form of the fundamental counting principle. Okay? We use the exponential form if repetition is allowed. Okay? I'm going to do an example just now. So if repetition is allowed, then we have to use the exponential form. When repetition is not allowed, we use what's called the factorial form. I'm going to show you how to do that as well by the end of the lesson. So, we have repetition there, which is allowed. Okay? Therefore, we use the exponential form. Okay? Now, when... Can I have your attention? Are you talking to me? Alright. When the repetition is not allowed, okay, when it comes to the fundamental counting principle, we use what's called the factorial form. Now, what does the factorial mean? Sorry, now, on your calculator, I'm just going to show you, then I will explain what this is about. 5 factorial. Now, 5 factorial means 5 times 4 times 3 times 2 times 1. Okay? So you multiply in descending order. Start with the largest, then followed by the next smallest, then the next smallest, until you get to 1. So, when we are answering questions on the fundamental counting principle, questions involving no repetition, okay, we use the what? The factorial form. If repetition is there, we use the exponential form. Don't worry, I will show you just now. So, just to summarize this, n factorial is the same as n times n minus 1 times n minus 2 times n minus 3 all the way up to times 1. Alright? Now, there is also another option on your calculator. Okay? There's also another option on your calculator, but you might not use this as well, but you can use it. It's now for permutations. Now, permutations are just arrangements of objects in a specific order. Okay? So, we have got this option. Permutations. I said permutations. Okay? Permutations are just arrangements of objects in a specific order. So, when we say it in maths, okay, let me show you on the calculator. Let me show you on the calculator. Now, if you go to your calculator, right, can you pay attention? Can you pay attention, please? On your calculator, where is your calculator? Where is your calculator? Okay. Now, if you go to the multiplication sign, right? So you have to press shift. Okay. So if you press, generally you have to put a specific number first. Like for example, let's say if I put 10, can I have your attention? So I say 10, okay? Now, those 10 would be the number of objects, but out of the 10, I might need only a specific number which is less than 10. So it would be 10, choose, maybe, we say 10, choose 4, okay? 10, choose 4, like this. So what this means is, we have got 10 objects, but among the 10, we just want what? 4. So if you press equals, it gives you an answer. Now, this same answer, I can get it as well if I type 10 factorial. Okay, let me show you. I'm going to do a proper example on the use of the calculator. So if I say 10, in this case here, it would be 10 factorial. Right? If I say 10 factorial, what answer do you get? Okay, it can't be 10. Right? It's not 10. Okay, all right, sorry. It will be, if I put in brackets, I have got 10 minus 4. Right? Then you close the bracket. Then you put the factorial. Okay, wait. It will be, okay, let's put the fraction option. Let's put the fraction option. It will be 10. Sorry, I'm in a rush. So n choose 4. So you've got 10 choose 4. Okay, so it will be 10 factorial divided by 10 minus 4. So that will give us 10 divided by 6 factorial. Right? So this will be 10 factorial divided by 6 factorial. It's not 7. Right? 6 factorial. And then you get 5040. Right? Remember, when I put 10 choose 4, can you stop talking? Can you stop talking? So, this notation, the factorial notation, and the one for permutation will give you the same result. But I would encourage you to use the factorial because this can be a little bit tricky for some people. You get what? Okay. All right. All right. Let's apply what I just said. Can I have your attention? Can I have your attention, please? I need to apply what I just said. All right. Now here we have got 7 digits. Okay. So use the digits 1 to 7. Okay. Rather using the digits 1 to 7. Right? How many 2-digit numbers can be formed if digits may be repeated? Okay? Now, if you want 2-digit numbers, it means you have got the first position and the second position. Right? If repetition is allowed, how many digits can take the first position? There are 7. Right? And how many digits can take the second position if repetition is allowed? Another 7. Then we use the fundamental what? Counting principle. So this will be the same as 7 squared, which will be equal to 49. So that will be 49 2-digit numbers. Well, let me warn you. If your mind is not focused, you might have issues here. Okay? I need your whole body, everything, to be focused. Right? Yes. This is the repetition case, whereby you use the exponential form. Right? You have got 7 digits, but there are only 2 positions. Okay. So in how many ways can you form 2-digit numbers? It will be 7 squared, it will be 49. Because the repetition is allowed. Right? Then the next one, yes? Yes. 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 So that's what we have in the second question. So the second question says, how many 4-digit numbers can be formed if digits may not be repeated? Now, this phrase here is very important. Right, so we have got 4-digit numbers, 1, 2, 3, 4. So out of those 7 digits, we need to create 4-digit numbers. How many 4-digit numbers can be created? Now, how many can take the first position? 7. And then, if no repetition is allowed, how many are left? 6. So the second position will be 6. Then the third it will be what? 5. And then 4. Then we use the fundamental counting principle, so that will be times now. So the answer there. Now this one here, it's more like 7 choose what? 4. Okay? I'm not talking to myself. Huh? You don't understand what? Alright. Okay. Look here. Look here. If you don't want to complicate things, then you can use your calculator, say 7 times 6 times 5 times 4, and then you get your answer. Huh? I told you about the beginning. Okay. The question says, can you please do me a favor and pay attention? It says, how many 4-digit numbers can be formed if digits may not be repeated? So we are given 7 digits, but you need to form 4-digit numbers from those 7 digits. Right? The first position of the 4-digit number can be taken by all 7 digits. Am I right there?
Yes, sir.
But you cannot repeat a digit. So the next position, how many are left? 6. Then 5. Then what? 4. Yes, it's always in descending order for a type of question like this. Some of you are busy giggling. Okay. Now this we can use the factorial. So this will be the same as 7 factorial divided by 7 minus 4, which is 3. Okay, you get the answer. If I use this formula here, okay, if I use that formula, because sometimes we have so many digits, right? So that's a shortcut way. But if you don't want to do it this way, just multiply 7 times 6 times 5 times 4, you get your answer. What answer do you get? 800 what? 40 like that. It will be 840 4-digit numbers. Yeah. Okay. Huh? Yes. Yes. Okay. Are you getting it? Yes. All right. Just to take you back, you know the car number plates. This is how they are generated by a computer. Because remember, a car number plate has got letters, then it also has numbers. So you never find a car with 2 cars that have got the same number plate. Okay? All right, let's move on to another example. Can I have your attention? Now, the next question says, all clients of a specific bank has a personal identity number, that's a PIN. Okay? Which consists of five digits chosen from the digits 0 to 9. Now, what's the total number of digits from 0 to 9?
9.
No. 10. How many personal identity numbers are possible? Okay, the first question, that's C1. The digits may be repeated. Right, now, please, there are Okay, it's not 10 times 10. 10 times 5. Okay, these pins, they must have 5 what? Digits. So we have got the first position, second, third, fourth, fifth. Right? There is repetition which is allowed. Can I have your attention? We want 5 digits here. The pin consists of 5 digits. Okay? But there are 9, so there are 10 in total. Okay? So the first position can be taken by all what? 10. Am I right? Huh? But repetition is what? Is allowed. So the second position is also 10. Are you following that? Yes. Right? The third position is also 10. The fourth, 10. The fifth, 10. And then you use the fundamental what? Counting principle. You see the 10, 10 to the power of 5. 10 to the power of 5, that's the 100,000. So, what this means is, from those 10 digits 0 to 9, you can create 100,000, okay, pins. 100,000 pins. Right? Then the next question. Are you following? Okay, if you need to ask, you need to ask this. Because I'm going to move on. Right? Then the digits may not be repeated. Yes. No. Okay. If the digits may not be repeated, right? The first position can be taken by all what? 10. Right? Am I right there? All 10 can take the first position. Okay? So all 10 can take that. Then repetition is not allowed. So if you put a digit in the first position here, how many are left? 9. So all those 9 can fight for the second position. Okay? Then we have used these 2 already. So how many are left? 8, then 7, and then what? 6. Then you use the fundamental counting principle. It will be 30,000? 240. Do you see that because of the restriction of not repeating digits, the number of pins decreases? Okay, if repetition is allowed, you get more pins. Right? Are you getting it?
Yes.
Okay, let's move on. Now, it's important. I'm gonna just summarize this because some of you are not paying attention. You are here physically, but you are not following. All right. So, whenever there is repetition, you use the exponential form. Okay? And then when there is no repetition, you use the factorial form. Okay? How do we know that that's the factorial form? I'm sure you can see that there's a decrease in the what? In the number of digits every position. All right? Okay, let's see if we've got another example. Right? Let's do this one before we go for break. Okay. Can I have your attention?
So is this what you use to make passwords?
Yes. Okay. So all right. Sorry, girls. If you want to manage to answer the last question of your paper, please, your paper 1, pay attention. Okay? Otherwise, you'll come out of a paper 1 trial and say, I didn't manage to answer the last question because you didn't know what to do. Alright. The question says, consider the word counted. How many letters are there? 7. Right? So the first question says, how many ways can the letters of the word be arranged if each letter must be used exactly once? So no repetition. Right? So So Jan, you are right. So we say number of ways. Number of ways, that will be 7 what? Factorial. Okay, now here, there is no need to write 7 times 6 times 5 times 4. You'll be wasting time. So you just write 7 what? Factorial, then you use your calculator quickly, you get your answer. What's the answer? 5,040 ways. Alright? Are you following? And then number 2 says how many 5-letter words can be formed from the letters of the word counted if no letter may be used more than once. Okay? So again, the repetition of a letter is not allowed. But we want to form 5-letter words. So we have got 1, 2, 3, 4, and 5 positions. Right? There are 7 letters. The first position can be occupied by all 7. Am I right? All 7 can fight for that position. Then, once you put a letter there, you can't repeat it. Which means here you will end up with 6, then 5, then 4, then 3. Then you apply the fundamental counting what? Principle. So, what answer would you get?
2,520.
2,000?
520.
2,520. That would be 2,520 words. They are actually 5-letter words. All right.